I'm sure you're all very excited to see fractions on this first page. Yes, we're going to revisit solving inequalities this time by clearing the fractions. Hopefully, since this is the third time you've seen it, it'll go really well. Starting off by finding the common denominator, what do 2, 3, and 4 all go into? And that is 12. We'll follow the golden rule and multiply everything by 12. Now remember, multiplying a fraction really means we're going to divide first. 12 divided by 2 is 6, but we didn't get rid of the times or the x. Minus 12 divided by 3 is 4 times 1. I know you know what 4 times 1 is. I'm going to show all my work and be very explicit for those of you who are still having a tough time with the fractions. We multiplied everything by a positive value, so I will not flip the inequality. 12 divided by 4 is 3 times the 3 that was left in the numerator. After we clear the fractions, we're going to simplify by multiplying our numbers and then solving the inequality like normal, adding that 4 to both sides. Adding does not flip the inequality symbol, and dividing both sides by 6. We're dividing by a positive, which does not flip the inequality symbol. You can leave your answer as an improper fraction. I'll show you how to graph that improper fraction on a number line. Setting up your number line, you're still going to put your solution in the center. It being positive, it's easier to just add a number to the numerator. Do not add a number to the denominator, and then subtract a number from the numerator. And that's how you can get your number line set up with a fraction. We have just less than, so that is an open circle. It's not or equal to, and less than shades to the left. Let's take a look at another one. This one also has an integer on the right-hand side. We're still going to follow that golden rule. Once we identify the common denominator, 5 and 6 both go into 30. We will multiply everything, including that integer, by 30. Starting on the left, 30 divided by 5 is 6 times the negative g, plus 30 divided by 6 is 5 times that 5 in the numerator. We multiplied by a positive value, so that does not flip the inequality, and 6 times 3 is 18, so 6 times 30 is 180. On the left-hand side, we're going to simplify. 6 times negative g is negative 6g, plus 5 times 5 is 25. Subtracting that 25 from both sides. Subtracting does not flip the inequality. Dividing both sides by negative 6 to solve for g. Dividing by a negative does flip the inequality. And negative 155 over 6 cannot be simplified. Graphing with fractions that are negative is slightly more challenging, just like graphing with integers that are negative is slightly more challenging. So make sure when you do one number to the right, which is larger, the negative values actually look smaller. So it's negative 154 over 6. And then to the left, we have negative 156 over 6. This time we have an or equal to, which is a solid circle, and g is greater than, so we're going to shade off to the right. Now we're going to learn about how inequalities can have special solutions. So similar to an equation, when you solved it and got a special solution, the variable would cancel. The same thing can happen with inequalities as well. Let's start off by distributing on the right-hand side. 14x minus 8. Then we can combine our like terms on the right-hand side. Negative 8 minus 3. So think about it. If you spend $8 and you spend 3 more, you have spent a total of $11. I like to get my variables together before my regular numbers. So when I subtract 14x from the left, it cancels. It also cancels on the right, leaving me with negative 11. My resulting inequality says 5 is less than negative 11, which is not true, so that means that this inequality has no solution. Our next inequality will simplify on the left by using distributive property. That gives us 6x plus 9 is greater than. On the right-hand side, we have like terms. Notice they're on the same side of the inequality. We're not going to try and cancel them. We're just going to combine them. 2x plus 4x gives me a total of 6x. When I cancel my 6x from the left, it also cancels on the right, leaving me with the inequality 9 is greater than 1. In this case, that is true. 9 is greater than 1. So this would mean all real numbers. You can signify that by simply writing all real numbers. There's also a symbol. It's an R with an extra bar, which means all real numbers. And to graph that on a number line, you would put any number in the center that you want to, and you would shade the entire number line. You have 2 U-Try questions.